I'm happy to introduce Adam Łukawski, who is at Meta Music X at the Orpheus Institute at Ghent, and Academy of Creative and Performing Art at the Leiden University. And he will be talking about a fractal of periodic space-time sequences as a framework for interoperable metaverses. So it's yours, Adam. You feel free to explain us your paper and your presentation. Thank you.
Well, thank you so much for having me here today. Before I explain what the fractal is of periodic space-time sequences, I would like to present a few quotes that were presented by Professor Paulo de Assis, with whom I work at the MetaMusic X cluster. They were presented for the conference about music NFTs back in May. And so what they describe, I selected a few of them, is the problem of interoperability of current blockchains and for the metaverses. Let's dive straight into these quotes. First of them is that blockchain technology is required to guarantee the reliability of data in the metaverse. And artificial intelligence is used to secure the diversity and rich content of the metaverse. So in this quote, we can see that blockchain technology and artificial intelligence together are somehow required for the metaverse. And this is from a paper from 2021. Next, this short but interesting quotation, that the economic system of metaverse must be constructed in a decentralized manner, such that virtual assets of avatars could be traded efficiently in the metaverse. Of avatars, any other assets, but what's important here, that the whole economic system of the metaverse should be constructed in a decentralized manner. 2022, as if I remember, quotation from March. Next one is that cross-chain interoperability is one of the crucial challenges preventing widespread adoption of blockchain applications right now. So cross-chain interoperability, what does it mean? We might build metaverse on Ethereum network, we might build another metaverse on Tezos network, but how are they interoperable? How can we then transfer data in between these chains as if they are universes by themselves? So here, as the final quotation, a blockchain is by construction made to be self-sufficient. So no blockchain by definition can rely on external data. So what does this mean? If we want to assert the validity of a transaction, we need to do this within one blockchain. So from this quotation, there is actually, what is speaking from this quotation is actually that we cannot create interoperable metaverse on the currently existing blockchains to zero. So what I would like to present today in this presentation is my idea for a solution, which here I would bluntly call it blockchain 3.0, but it's just a different kind of blockchain that could be created to solve that problem. So to compare it with already existing blockchains, in blockchain 1.0, for instance, Bitcoin, as you know, only cryptocurrencies were established. It was established to avoid, for instance, a bank to send a transaction between two interested parties. In blockchain 2.0 in 2014, there was smart contracts idea that enabled new types of various applications, for instance, decentralized applications, NFTs, and already mentioned also today, DAOs. But now the question would be, how do we change the information in the blockchain to enable this interoperable metaverse? So I would like to introduce two basic concepts that would be in such transactions. And these concepts would be also kind of based on smart contracts, but what I call them is the observers and belonging to them environments. So what are these? So environment would be a kind of a smart contract owned by an observer. It would describe the rules of the metaverse. So this would be, for instance, physics of the 3D world. a musical system. So whatever the metaverse will be now, the metaverse, just think of it, this could be a virtual world, but this could be a collection of objects that we would like to share. What these objects are is then subject to definition. And another definition I would like to establish here is the observer, which would be either a human or an AI agent. So this human or AI agent would create blockchains by interacting with environments. So then, how would this look like in practice? So if this, what you can see now on the presentation slide, would be the Genesis block number 1, we would have the environment, which is the smart contract, a set of rules in which we describe the rules of the game, the rules of the environment, it's physics, for instance. And we also have the system state. Now, as an observer, for instance, as a human observer, I might want to introduce a change to the system state. So let's imagine that the current system state is that we are on the football field and that there is a football ball, and I would like to kick towards trying to scoring the goal. So I want to introduce the change in the environment as an observer, but whether this will be according to the rules, so whether I will succeed playing this game is not automatically given. So what I would first transcribe to the block number 2 would be my intended change. So this intended change has to, in some way, speak to the environment. So then intended change would be transferred to the environment, which would then calculate whether my intended move, what is the actual result of this transaction, which would then provide another system state. So we could then follow this forever, creating a blockchain-based transaction, which I call in this sense a performative transaction. So this would be what observers perform in this new kind of blockchain for the metaverse. Now, here's a version we've extended by the user interface. So how do we interact with the blockchain? This could be, of course, by virtual reality goggles, but maybe there are already also other technologies being developed we still don't know about. Maybe this will be in another way. Well, here in this very generic graph, there's user interface in between. So this is the way how we interact with the metaverse. This type of blockchains, they create a new notion of private and public space. So there is a question, how do we distribute these types of blockchains? Well, environments could be started by an observer, so whether by a human or an AI agent, just as a private local space. So this does not have to go to, now I would call it a centralized blockchain, and then I would say Ethereum blockchain belonging to the community. It can be on my local computer, a local space. I do create changes to an environment maybe designed by me. Now, this environment, well, I can distribute it with other observers directly. So if I'm interested in sharing my metaverse with one of you, you would need to have the whole copy of that blockchain. So in fact, if we will be speaking about consensus mechanism being part of such a blockchain, it would be a blockchain by itself, blockchain with 2 participants. So as any distributed space could be then copied and continued as a private local space. So what does it mean? Let's say that everyone in this room participates in one of such blockchains, but so we all have a copy of such a metaverse on our local computers, and we contribute to this with our changes. So if I would be suddenly not interested in contributing to this blockchain anymore, I could just follow my own copy, right? And I could just copy it and continue separate blockchain. So the last part is, there would be no central blockchain. There would be only decentralized direct peer-to-peer connections for working on the same blockchains. And I'm really thinking about this as kind of trying to satisfy this promise of actual decentralization in blockchains, because as we spoke already before today, we can already observe now 6 years after the development of smart contracts that actually we are shifting the power, but there is no democratization in the current notion of blockchain to zero. So just as a visualization of this kind of architecture, as you can see, we have several observers, whether humans or AI agents. They contribute to these different environments. But in this, just imagine that these environments, everyone stores copies of them in the blockchain itself. So they are not really separate, but this is how they would interact. So now, after establishing such a framework, so a very general system that would be distributed, then I am interested also in designing such an environment. So then the next question is, once we have a framework, what would be the ways of establishing environments to help users use such a blockchain? So as an inspiration, I use assemblage theory. And in my paper, I describe more precisely, but for the sake of time, I explained here that it is a method for analyzing and modeling changes in the environment. And digital assets in such a model would not be analyzed structurally. So not as stable objects, we would not require a string of data for every moving object. But being inspired by assemblage theory, I'm speaking of topological unfoldings. They will be certain kind of periodic assemblies limited to the topology of the space they are located within. So now this might sound difficult, but it will sound less and less difficult as we follow. So these assemblies would be listed in kind of special diagrams. So I'm designing an algorithm for a space of any size. What are the possible kind of topologically unfoldings within that space? So it would be constructed by a set of rules of these unfoldings. And what would this enable? This would be an algorithm that enables to use just one short string of text that would be capable of describing any progression of events, also infinitely long, but within some certain periodicity. To achieve this kind of algorithm, I was inspired by Shepard tones. And Shepard tone is a musical loop with gradually increasing or decreasing musical scale that creates an aural illusion of infinitely raising or decreasing pitch. It was designed actually at Stanford University by Roger Shepard, cognitive scientist. And well, here's a quick example of such a Shepard tone. The sound of which I generated, and it is an equivalent, the barber's paw is a visual equivalent of that kind of illusion. So as you can hear, this sound kind of infinitely raises in pitch, but in fact we already probably listened to 15 loops of the same file, so we could listen to this forever and we would still be tricked that this is infinitely raising pitch. So then, analyzing the Shepard tone, we could understand it as one spatial dimension changing in discrete time. So as you can see, this Shepard tone as a musical example in a notation, there's a line, and if we play back the file, we can listen to the musical material changing in time. So the Shepard tone of these two examples, I understand as one spatial dimension changing in time. Now, the musical material can be modified in such a way that any musical piece is found before the next repetition of the loop. What do I mean by this? As you can see, we have a raising progression, which is periodic. It works in a way that each line has to finish before the start of the next line. So they come into this periodicity. But what I was discovering for the last 3 years is that actually you could put the Fifth Symphony of Beethoven in the middle and make it periodic, so coming back to its own beginning, if you find algorithmically a set of parameters how to change this periodicity. So then also this periodicity of Shepard tones could be generalized to actually any time evolving dimension. So there could be one spatial dimension changing in time. But we could also imagine that there's a moving image which is changing in time. like two-dimensional space, changing in time, or moving 3D objects in the metaverse. So before I go on with the algorithm, at some point I realized that if we generalize shepherd tones to n dimension, this can go to any amount of dimensions. Actually, we could speak of, well, mathematical periodic sequences representing these spatial temporal movements. So what are mathematical periodic sequences? Well, in terms of, when we have progression of terms in a sequence, let's just imagine we have some progression of recurring discrete values. And well, the simplest object of the sort, as you can see on the picture, is a periodic sequence with period 1, which is a constant function. What does it mean? And here, especially, I put an example from a 3D space. As you can see, well, we have some square, and this square exists in a 3D plane, but it loops back to itself constantly. So for an observer observing this object in time, what this means is actually that we see an object not changing its state. But then we could have more time frames. So these time frames are, as in this example, in a periodic sequence with two terms, so two time frames, there are two constantly repeating time frames, A1, A2. And if for the observer, only one of them is actual at any given time. So we would see this progression of two states constantly changing if we would be watching this object with two terms. Well, mathematically, it's limited by the topological space. So this type of object would only have a possibility to move in one direction if it would be to move at all. So then, yeah, it does not matter if this sequence starts from the first or the second term because its continuation remains the same. So we could say that whether it starts from number 1 or 2, topologically is the same object. And now, well, here's a short example, 4 periodic terms in 2 spatial plus 1 time dimension. As you can see, this starts creating these shepherd tone-like progressions, but here example for instance, in 2D space. So I generalized a method to find one algorithm to describe with a short string of data practically any progression of topologically changing objects in spaces. And as you can see, this generates this kind of fractal of possibilities. And this is up to the 12th level, which is 12 time frames. It's a list of possible modifications. And what's interesting is a universal shape no matter the amount of dimensions. So for 10 dimensions, it will still look like this fractal. So I described the algorithm in detail in the paper. But then I would like to briefly talk about layers of assemblage. So we could, with this method, just with a short string of text, describe not only the assets themselves, also positions of assets against each other, and then also positions of observers. So in fact, this state that is being designed in a blockchain could be with a string of data in each blockchain. It's kind of like a hash for describing the metaverse reality. So then just the very last point is that since I'm already designing a general method for a general environment, as a musical composer, I am also interested in designing environments for music. So what would be, for instance, basic rules for using this idea for music composition? Well, I'm establishing just very short two rules to apply this method to music scores. For instance, if there are 2 frames with the same type of an object, which are in a consecutive line, this could create longer rhythm. So as you can see from the first and second line, we have on quarter notes, we create half tones. And there's example of how this generates sounds. And for dynamics, it could be that 2 objects of the same type are in the same frame, which creates a louder sound. Well, this is for instance, and of course, could be subject to different systems. So not necessarily play the example now, but here are just visually some examples. So as you can see, there's a short string of text above the score, and underneath there's a score being generated by a computer program that I'm developing with this just short string of text. So it's already kind of a compression of data format as well. I did already use the method for composition of actual music, but I think this will be interesting for the evening, as I did send the video of this musical piece to the exhibition space. So if you're interested, you can listen to this musical composition composed with this method. And this is the presentation. Thank you so much.
Well, thank you for your presentation. If you have any question, feel free to ask. If you don't have, maybe I found it really interesting because, the question of interoperability is really important. And as you said, blockchain is not supposed to be interoperable. It's supposed to be, well, working by itself. But we have a notion called the oracles. And what's the link between oracles that were proposed, for example, on the astronomical system, and the notion of observer you are proposing in your blockchain number 3? What are the link between two? What's the differences?
Well, I would say this is a very different system because oracles were constructed to bring data off-chain to the chain, like on Ethereum. And in this case, we could say everything would be on-chain, but it's just a really different system. In blockchain 2.0, everything has to be public. And so the reason blockchain 2.0 actually exists is the immutability of data being accepted by everyone. In this blockchain, I would say, if you keep your blockchain on your own local computer and only with interested parties, then, well, it's really decentralized. Nobody actually has access to verify whether data is on-chain or off-chain. Everything is on-chain and everyone actually stores all this data. So I would say oracles were solving the problems of blockchain 2.0, which would probably not be the case in this new blockchain.
I understand the fact that to want to make everything on-chain to keep like I understand that. Okay. I understand the fact to make everything on-chain to keep like the permanency of the metaverse, but in most of what we see now, if you take, for example, Axie Infinity in terms of gaming, they don't want to store everything on-chain because they believe that it's a bit pointless, because they believe that, for example, they can time frame what's happening during like 15, 10 minutes, and they just write on-chain the result of it. In what I understand about your proposal, if you are going to store 100% of all the information on-chain, and I didn't get like the use of it compared to, for example, side chaining, lightning ID sharding. There is also like many other ideas to say that we don't want to store essentially 100%. We just want to store like the result of what's happening on the side. So in your proposal, if I'm right, you're storing like 100% of everything happening, right?
Well, I think the best way of seeing this proposed blockchain is comparing it to GitHub. So this is kind of like a really decentralized version control. The difference is that in GitHub, we do have one centralized website we can at least refer to see all the possible blocks or all the possible programs being developed and they are forking, etc. But just in this case, we do not have such a centralized website. So it's really kind of more like an internet that if you don't know the address, you will not connect to the website. So in a sense, well, answering why everything is being stored on chain, I would say it's not the way of thinking that like in the Ethereum, the whole community has to keep everything. But the main reason for an economical incentive in Ethereum is actually that we want, like previously miners and now in the future stakeholders, to actually be doing this work for us. But in this system, we do not have to classify as observers and maybe some miners, because my main incentive is I want to participate in the metaverse, right? So if I want to participate and somebody else also wants to participate, well, we can do this job for ourselves and we don't have to pay anyone. So I wouldn't say this blockchain is about financial operations. And if you would like, for instance, in this blockchain, keep the ownership of some object, well, you could always use blockchain 2.0, which is already perfectly designed just for that, for some community to agree on your ownership of some object in blockchain 3.0. I don't know if this, yeah.
And just my second question was about the way that you design like the space in your metaverse by using this kind of loop. Is it kind of the same thing because we were speaking about music, like what did, for example, Steve Reich with clapping music? It's kind of small loop that you just interact to create like a new composition and kind of fractal space.
Well, no, it's very different. For Reich, it's just really designing loops and shifting them in between each other. And in this case, it's just finding a way of describing topological closed spaces. So it's more of a mathematical function. Yeah.
Okay, thank you. So maybe we can move to the next session. Thank you.